Okay, so let's have a look at this. We've got three reaction schemes here for reaction schemes 2. So problem 7, problem 8, problem 9. So what we need to do here is identify the type of reaction that's occurring, the missing reactant or product, and missing reagent if we need to. So what I'd like you to do is just pause the video and then have a go and see if you can complete this reaction scheme, and then start it again and see if you get the same answer as me. Okay, so if we start with the first one here, we can see that we have a butan-1-ol, which is a primary alcohol. Now, primary alcohol we know can be oxidized to an aldehyde and then on further to a carboxylic acid. If we carry out this reaction and we set up as a distillation, we can separate the aldehyde. However, if we carry out this reaction under reflux, if we're oxidizing this using permanganate, acidified permanganate under reflux, it will make sure that the reaction goes to completion and produces the carboxylic acid. So this is an oxidation reaction, and we are going to draw the carboxylic acid that this would form in this middle box here. Now, if this is a carboxylic acid and we want to turn it to an acyl chloride, we need to think about what type of reaction this is. So remember, what we're doing is we're replacing the hydroxy group here with a chlorine. So this is a substitution reaction, and the reagents we can use are PCl5, PCl3, or SOCl2. And in this case, I've written down PCl3. Okay, for problem 8. Well, let's start at the bottom. At the bottom here, I have a primary amide. Now, the only way that we're going to be making this primary amide from this type of reaction scheme is actually if we have an acyl chloride, okay, and we carry out a substitution reaction. So let's put in the acyl chloride here. So what we're replacing is the chlorine with an NH2. So we're going to be adding, this is a substitution reaction, and we're going to be adding NH3. And the NH3 is dissolved in alcohol, or we could write it concentrated NH3. Now, above this acyl chloride here, we can see we added SOCl2 to make the acyl chloride, but what is it that we would have created it from? Well, if we remember the reactions that we've gone over, the substitution reactions, an acyl chloride can be made from a carboxylic acid. So this is the carboxylic acid that we made it from. And this must be a substitution reaction as well. And finally, well, what did we produce the carboxylic acid from? Here it says the reagent they used was Tollens reagent. Okay, so if we remember Tollens reagent, we know that Tollens reagent will only work with an aldehyde. It's only strong enough oxidizer to oxidize an aldehyde. It won't oxidize an alcohol. So we're drawing for compound B here, that aldehyde that would make this carboxylic acid. This must be an oxidation reduction, and here is the aldehyde, so that is pentanal there. And that is problem 8 completed. Okay, so let's have a look at problem 9. So with problem 9, I can see that if I start with this haloalkane, I can produce a molecule that will go on to produce an alcohol. Now the alcohol is only one of the products produced from the second reaction. So this must be a reaction where there are two different options where to add the functional group. And if we think about this here, it makes sense if we carry out an elimination reaction. And actually the reagent here, potassium hydroxide dissolved in alcohol, will carry out an elimination reaction of a haloalkane, and it will turn it into an alkene. So this is an elimination reaction, and it turns it into an alkene. Notice here what we've done is we have added to this to produce this primary alcohol, and what we've done is we've added the hydrogen has added to the carbon of the double bond that has the least hydrogens. So this is actually the minor product on the right hand side. So we're going to draw the major product of this on the left hand side, and that's the one when we break the double bond and add the H and the OH. The H will go to the carbon with the most H's the majority of the time, and that's the first one. And that would be an addition reaction, and we add water in the presence of dilute acid, and here's our product to produce. It's a secondary alcohol, propane 2-ol. Now, if I want to now go on and react propane 2-ol, if I'm going to do a similar type of reaction that I do here, an oxidation reaction, and I could use acidified permanganate or acidified dichromate, I'm using dichromate, I can turn this into a ketone. If I carry out using permanganate, and I'm using a distillation apparatus here, it's highly likely that I don't want to produce the carboxylic acid, but only the aldehyde. So I'm still going to carry out an oxidation reaction here, and I'm going to produce the aldehyde. And that is the reaction scheme completed. Well done, if you got most of it right.
Hey, thanks for watching this video. Hopefully this has made you more confident with your chemistry. Don't forget to like, subscribe, or leave a comment about anything that you want to with this video or any questions you have. I'll see you later.